Hey everybody. 3 types of thinking that will make you better mathematicians are noticing things and wondering things and trying to generalize results. So exploration number 1 is going to give you an opportunity to do all 3 of those things. So this is the function 1 over x, and you'll notice that as I drag around the tangent line, we've got sort of a triangle here in the first quadrant. You imagine this red line plus the 2 axes are a triangle. And I see the triangle moving around, and then you can also imagine what if we formed a rectangle with the axes and the point of tangency here. So obviously because 1 over x has this nice symmetry to it, when I have an x value of 1, the y value is 1, and the rectangle becomes a square, and the triangle becomes an isosceles right triangle. So here are some things I'm wondering about. When I move around the point of tangency, I'm wondering how does that affect the overall area of that triangle. So that's one thing. Obviously the area of this rectangle is also changing, so I'm kind of interested in that. And I guess a third thing I could be interested in is if I'm going to think about like the ratio of the area of the triangle to the area of the rectangle, I want to know what point, what x value will maximize that ratio. The ratio of the triangle area to the rectangle area. So those are the things that I want you to investigate, and you can answer the specific questions on the handout because they're just a restatement of what I said here. And then once we're done with that, we want to try and generalize the results. So instead of just looking at 1 over x, what happens if we look at 1 over x to the n for various values of n? So here, when I make it 1 over x squared, now let me restrict the domain here, so x greater than 0. Okay, so when it's 1 over x squared, now all of a sudden the curve doesn't have that nice symmetry anymore. You'll notice that at the point 1, 1, we don't have an isosceles right triangle. Now we've got sort of a different thing. But I want to know, whatever results you came up with for the 1 over x function, are there analogous results that hold for this function, for the 1 over x squared? What if we were going to do sort of the other direction, x to the 1/2, which is skewed in the other direction? So that's the goal of exploration number 1.